So, welcome, champions Vyshakh, Venkat, and myself. We have run three different approaches to pen test the same targets. We have the results. Today is the moment of truth. Okay, so previously I already compared Venkat yours and mine. Yours using Transilience and multiple agents, and mine using Strix. And now we have Vyshakh, which is using MCPs.
Sure. Yeah.
So now let's compare all three. And one of the reasons we're using Manus is because Claude um, just fails. Venkat, you tried it, I tried it. Gemini, which we just tried, removes Venkat's zip file because it has some Python scripts and some POCs and stuff like that. Manus does what it is asked to do. So while Manus does this, let's quickly walk through our individual setups just to remind folks how we had set things up. Let me start that off. I have Strix installed in this Kali Linux box. The installation was pretty simple. It works exactly as advertised on the README file. It's essentially a single command. Then you export your variable for the LLM you want to use, and then you export your key for that LLM, and then that's it. You run the scan. So essentially, whatever your target system is, you run it. And when I do this, as I have shown in the initial video of Strix, it spawns up a bunch of agents as per what it discovers, and then creates additional agents on the fly. The part that I found a little um, not impressive was that I wasn't sure if I can interact with it as we go along. So while it starts pretty impressively and it does a good job, but I was not sure if I can, for example, give it instructions in this text box while it's running, and can I influence its working, and will it disrupt what it's doing, etc. So I'm sure that it will take those commands. The other thing which I also wanted to highlight was that the output, as we can see here, this is the unzipped folder. The output is essentially just a Markdown file. Whereas Vyshakh, you got a pretty impressive PDF report, I would say. So this is almost a customer ready report, more or less. And so I like
Mhm.
that. For me, it would require an additional step to give this data to a Claude or somebody and ask it to generate a report from here. Uh, so yeah, over to you guys. Do you want to walk through your setups?
I can go next. So in my case, I used Claude and with their MCP feature, on their Pro plan, I integrated multiple tools. Initially, it was three. It was, I can show you in the developer region. Yeah, I had Burp, Perplexity, and Kali. It will show error, but it runs still. And after the challenges, I wanted to tinker around and check what kind of another MCPs I can integrate to maybe broaden the pen testing features in my Claude LLM. And it did work. There are some configuration issue which I'm working with. The configuring part of these tools may vary because Burp is pretty straightforward, as I can show you. If you install from the extension from the Burp store, uh, if you search MCP, you can directly install this to your Burp. It will create a tab, and you can just enable and set up some checkboxes as per your requirements. And in the in the last part for the installation, it shows install to cloud desktop. Now, what it does is this has an embedded code, a JSON format, and that code is embedded to a Claude's desktop configuration file, which is this one. Now, if you can see, I have multiple ones, but this is the one which Claude embedded in my JSON file, and it was pretty straightforward. I had nothing to do with it. I didn't change anything. It just printed on my JSON file, and it worked very magically. And Perplexity also was normal, but Kali, there was some issue. There are multiple ways to install, or integrate Kali, like using WSL, SSH, any kind of another format. But I had to tinker, initiate a VM. I think I can show you the VM also here, and install MCP Kali using the sudo apt repository. And then I had to install a Python file in my Windows machine, and I had to establish a connection between them. Now, in the Windows, it has a connector, and in the VM, it has a listener. So how it does is, when LLM understand what I want to do or what it needs to execute, it sends like a post request to Kali, and Kali understands it and executes the command, and it gives you a result from the post command, and LLM or the Claude analyzes it and summarizes it.
So Venkat, over to you.
Yeah. So here, what I did in my approach is entirely custom. There's no agentic, open source agentic or commercial agentic security per se. It's all custom made. It uses the Claude agents framework, and practically it works with any Claude or Gemini or any even codex. The framework here is that you have a directory where the directory explains everything that you want to do, and then the LLM command will work on these files and will faithfully execute what you want. So here's a cloud.md file. Essentially, it states that this is a project that will do pen testing for a given application, and this has specialist agents, and each of the agents are described in each of the files here. And put the output directory, put the scripts, reports, etc. in the output directory, some instructions around. The way it works is that here's my directory, and if cd.to.cloud, and you can see all my files here, the agents and skills. So once you have everything set up, you just run something like this, where you run Claude, do pen testing of the app, you do the command, and then it'll go and look at your cloud.md and then follow through the process. It'll look at the cloud.md file. The cloud.md file says that there are agents and skills. It'll follow through with what skills it has, and each skill will call each of the agents, and it'll run through all the skills and all the agents. And you can essentially do the same thing with Gemini as well. You can say same with, you can say Gemini dash YOLO, do the pen testing, and essentially it will pick up the Gemini.md file, which essentially is the same file as Claude. It will run through the same agents. So I organize the files into skills and agents. Each skill is a combination of multiple agents. For example, I organized all the inventories stuff into one skill. I call it web application mapping, and it uses 3 agents to scan directories, to scan APIs, to scan for files, to scan for software, and each of those agents are directed here. The agent file essentially starts with what it does, what tools it uses. For items where it needs a little bit of a nudge, I asked Cursor to pick up specific open source files. For example, I think here directory scanner will mention a few files like GoBuster, Nikito, Dersearch, Firox Buster, FF, and these are the open source binaries that Cursor has recommended to put in. So in this case, if there are binaries recommended, it will run through those files. If not, it will it will go through and write code to accomplish its tasks. After all it's done, I directed it to put the output files in specific places. So reports, this is a markdown file of everything that it found. There is executed summary, critical findings. More importantly, I thought that it's more important for including the reproducibility of the results easily for the user. So asked it to include, for any proof of concept, include the scripts that it used to find the POC, and a README file to how to run and how to reproduce the results. So all the scripts and everything else that are needed to POC are neatly bundled up in one directory. That is the framework. That is all.
So Venkat, essentially a large part of this you coded as we code everything today, which is largely through multiple prompts, multi-shot prompts, and created the skill files, created the agent files, created that directory structure. How easy or difficult would it be to add functionality? Let's say if you want to do red teaming of AI powered apps, basically prompt injection, like launch 100,000 prompt injection attempts at a target system.
It's quite easy, almost zero work. I can actually here, since you asked, I can quickly here say, can you add an agent to test AI prompt injection? So here, for example, I just said in cursor to add an agent to test AI prompt injection. Now it's reading through the existing agent structure, and it's going to create a markdown file that essentially states, here, for example, it's writing the agent file here, your responsibilities, it understood the structure. And then I'm sure it's going to search a little bit around what it means for AI prompt injection. So here, browser tools, command tools, what is prompt injection. I'm sure it will put in pirate if needed. So that is how easy it is to customize it or change reporting structure or add new capabilities, etc.
Amazing. Cool. So now the moment of truth. Let's go and figure out what Manus thinks of all of our reports. By the way, we manually did review the reports. So the conclusion is, for exhaustive coverage and deep discovery, Venkat's report is superior. Venkat, I think you win this. It found the most vulnerabilities and the most critical RC. For formal compliance-ready reporting, VAYSHAKH's report is the best. Its professional structure, CVSS scoring, and compliance analysis are ideal for executive and regulatory review. This is what I said, right? When I looked at your document, VAYSHAKH, it looked like a report that we could send out to the customer. For quick, high-impact prioritization, so basically what Strix did was like a very basic test. I don't think it reached the level of comprehensiveness and coverage that Venkat, you and Vyshakh reached. And in terms of testing, coverage, and deep discovery, Venkat, you win. The gap obviously is that when we look at your output at this stage, it requires one more step, which is to ask one of the AIs to generate a professional looking report from these markdown files. So while a lot of detailing is there, a lot of tests were run, and the POCs are also there, right? There's a lot of proofs of concept for everything that was found. What we need now is a professional looking report of the way that Vyshakh produced. But from a testing perspective, I think we have a clear winner. A robust security program should leverage the strengths of all three. This is, I think, AI just being super nice as they always are. The discovery depth of Venkat's platform should be used to identify all flaws, while reporting should be from Vyshakh, and impact chaining focus of KK's report provides a valuable perspective. The most critical finding, the WorkZia debug console exposure, was only identified by Venkat's report, underscoring the value of its specialized exhaustive testing agents, etc., etc. So now we will make this report public as part of this research that we have done. And Venkat, am I right in saying that we will also be making all of our code
open source
and sharing with the community?
Yes, yeah.
That's awesome.
I think we just got started on this. There is a lot more work to do in terms of everything, in terms of expanding the skill, digging deep into each of these types of attacks. So we need community support on this. So we're going to open source this.
Awesome. And there's so much exciting stuff to do, right? Graybox testing, API testing, mobile app testing, AI testing. We can really cover a lot of ground, and I think we should be able to do it at a fairly quick pace. So excited about how this open source project progresses. Good show, guys. Thank you everybody for participating. I think this was a great learning experience using a lot of these tools. And I can see Venkat smiling like a proud father would smile at a child's accomplishment that your kid has come first in class, Venkat.